Hi. So today we are going to discuss about some more divisibility rules. In the previous video we have learnt about divisibility rules of 2 and higher powers and 5 and higher powers. So in this video we are going to talk about divisibility by 9 and 11. So my question to you all is, how do you check whether a number is divisible by 9? So some of you may recall your school days. So that how do you check whether a number is divisible by 9? We just need to add all the digits and then we can see whether the sum is divisible by 9 or not. If that sum is divisible by 9, it means number is divisible by 9, otherwise not. Now, my question to all of you is, why so? Let's check here. So let my number is a 4-digit number, ABCD. So I have told you in the previous videos also that while working with numbers, there are two important tools which we must use and we should be careful about. One is the place value. We can expand the number according to place value, and another one is the prime factorization of the numbers. Okay, in this case, I have written this number in its expanded form according to place value. So this A is at thousands place, so it is 1000A. B is at hundreds place, so it is 100B, and then C and D. Okay, now I want to check what will be the remainder when my number is divided by 9. Okay, let's see this. So if I divide this D by 9, so what will be remaining? D is as it is. Whatever is the value of D, that is the remaining part. Okay, what about 10C? If I divide this 10C by 9, what will be remainder? See, 10C is not, 10 is not divisible by 9. So, but near 10, I have a number which is multiple of 9. I can break this number as 9C plus C, isn't it? It means this 9C is always going to be divisible by 9, whatever may be the value of C. So, what is going to remain here is C only. This D was positive, so this C is also going to be positive. This is plus C here. Okay, similarly for 100B, can you see any number near 100B which is multiple of 9 always? Yes, it is 99B. So 99B plus B. So 99B is divisible, remaining is going to be plus B. So this plus B is the remaining part. And similarly near this number 1000A, the number which is multiple of 9 always, it is 999 times A. So what is remaining is A. Okay, so beside this A, B, C and D, whatever part is left, that is always going to be multiple of 9 or divisible by 9 irrespective of values of A, B, C and D. Now what is remaining is this A plus B plus C plus D, which means if this remaining part is divisible by 9, my complete number is going to be divisible by 9. So wasn't this the same rule which you reminded in your schools, you learned in your schools? Yes, so that's the rule. The rule is right, whatever we have learned. So we have just tried to understand why it works. Now, so how to check whether a number is divisible by 9 or not? We can conclude in a manner that we just need to divide the complete number in groups of 1 digit, taking from the rightmost part. So I can write it as, okay, we are to make groups of 1 digit at a time. I'm writing here like this. So we are to divide the number as a single digit, taking 1 digit at a time from the rightmost digit, and all the digits, what we are to do with them, they are to be added. So they are to be added to each other. So I'm writing it here with this plus sign. So we are to add those digits, and then we are to check final value whether that number, whether that final part is divisible by 9 or not. If it is not divisible, so whatever is going to remain, that is going to be my remainder. Okay. So now, isn't it the same rule for divisibility by 3 also? Now here is very important thing to understand that when I'm checking divisibility by 9, so if a number is going to be divisible by 9, it is going to be divisible by all of its factors, and 3 is just a factor of 9. Say in this case, we had left this 9C. So 9C is divisible by 9. So isn't it divisible by 3 also? Yes. So if I need to make a rule for divisibility by 3, so again I'm going to left 9C here. Whatever is going to remain is C only. Same way here also, 99B is divisible by 9. So it is divisible by 3 also. So what is going to remain is B only. And same way A only. Which means in general, I can say if this is the divisibility rule of 9, so it is going to be available, or it is going to be valid for its factors also, and factorization of this number is 3 square. So this rule which you have just confirmed, which you have just concluded, is valid for 9 and as well as 3. Okay, let's move further. What if I want to check whether my number is divisible by 99 or not? I'm writing 99 here. Now you may not have done this rule in your schools. So how can we check whether a number is divisible by 99? So we'll make use of the same method which we have just done here, and for you I have done it here. See, if I'm checking divisibility by 99, so this D is not going to be divisible by 99 ever, 10C is also not going to be divisible, but this 100B has a number which is multiple of 99. Yes, if I break it as 99B plus B, so then 99B is divisible. What is going to remain is only B part, which means the number when it is multiple of 100, that part is going to be divisible, and prior to that, the last two digits, they are not going to be divisible. So now what I'm doing, I'm splitting this number, I'm making the groups of this number 2 digits at a time, as I have done here. So I can write this number as this CD as it is. This AB is at the hundreds part, so I can write it as 100AB. So this is my number now. Now, if I divide this number with 99, so this CD is going to remain as it is. This will be CD only. And in this case, 100AB, I can split this number as 99AB plus AB. So 99AB is going to be divisible by 99 every time, whatever be the value of this 2-digit number AB. So what is going to remain is plus AB. So this AB is positive and this CD is also positive. So again, we are getting almost similar rule as we have got for 9. So, but now in this case, what is the difference? Now we are to divide the numbers in groups where each group is having 2 digits, and this grouping is to start from the rightmost digit of my number. So rule is almost same. I need to add all the groups, and in the group, I need to take now 2 digits at a time. And I need to remember that the grouping is to start from rightmost digit. It means if my number is, say, I'm writing number here. If my number is, let's say, 1, 2, 3, 4, 5, and say 6, 7 also. So how do I check whether this number is divisible by 99 or not? So I can quickly make use of this rule. So I need to make groups of 2 digits at a time, starting from the rightmost digit. So this is a group 67. This is positive. This 45 is also positive. Then this 23. This is also positive, and this one is also positive. So what I need to do, I just need to add all these and see whatever is the value. So whatever is the value, that if it is divisible by 99, my whole number is divisible by 99. Otherwise, whatever is remaining is my remainder. Okay, let's do it quickly. If I add them, so 67 plus 45 is 112. 112 plus 23 is how much? 112 plus 23 is 135. 135 plus 1 is 136. So this value comes out to be 136. I have just done 1 plus 23 plus 45 plus 67, and this comes out to be, I forgot, sorry, it's 112, and 112 plus 23 is 135, 135 plus 1, 136. Okay, now this 136, whether this number is divisible by 99 or not, certainly it is not divisible. So what is the remainder? Okay, 99 is easier. I can easily find out 99 is the, if leaving out 99, I'm left with 37. But I can make use of this, my same rule again here. How? I can again split this number according to the following pattern. Means I can again do the grouping. This 36 is going to be positive part, and this one is the next part, which is again positive. So final remainder is going to be 37. That means this complete 7-digit number is 37 more than a multiple of 99. So if I subtract 37 from this, this number is going to be divisible by 99. Or if I add the remaining part, so that it can also become divisible by 99. Okay, I hope this is clear. Can we extend this rule further also? Yes, that is the amazing part here. If I want to find the rule for 999, I missed one part here. This rule is valid for 99. Does this rule works for other numbers as well? Yes, we had just talked this, that this rule is going to be valid for all of factors of 99 also. So what are the factors of 99? Can you think of any? Yes, 99 can be written as 9 times 11. I can write this number as 9 times 11. So this rule is going to be valid for 11 as well. This rule is going to be valid for 9 as well. And it's factor 3 also and 33 also. All the factors possible for this number 99. So that's the important rule here. So for 9 we had one rule earlier, and now we have another rule for 9 also. Okay, let's come to this 999 part. So for 999, going by the previous pattern, we can easily think that what is going to happen. It's going to happen same thing. I need to make now a group of 3 digits. Let's see here. I've done this for you here. So if I divide this number taking 3 digits at a time, and this grouping is to start from the rightmost digit. So I am taking BCD together as a 3 digits number, and this A is at thousands place, so it is 1000A. Okay, so in this number 1000A plus BCD, so this BCD 3 digits number will remain as it is, because when divided by 999, so this number is going to leave. It is not going to be divisible by 999 anyway. And in this 1000A, 999A is divisible. So what is going to remain? It is A only. So this BCD was positive and this A is also positive. So it's almost similar rule. Now you have concluded easily that now we need to take groups of 3 digits at a time, starting from the rightmost digits. That you must always remember, that should not be forgotten, and all the groups are to be added. And finally, for what numbers this rule is going to apply, it is going to be applicable for all of the factors of this number 999. Now that is a very important part. What are the factors of 999? 999 is 9 times 111, and 111 can have further divisible by 3, so it is 3 times more 37. So finally it comes out to be 27 into 37. And 27 has factors 3, 3 square, 3 cube. This is 27 is 3 cube. So this rule of taking 3 digits at a time and adding all the digits is going to be valid for all the factors of this number. Means it is valid for 3, it is valid for 9, it is valid for 27, it is valid for 37, it is valid for 37 times 3, that is 111, it is valid for 37 times 9, that is 333, and of course 999. So without writing much, let's immediately jump to next number also. What if my divisor is 9999? So 4 times 9. So what is going to be the rule? Yes, now we need to make the groups of 4 digits at a time, and this grouping is to be done taking the digits from the rightmost digits, last digits, unit digits. So we are to make groups of 4 digits at a time, starting from the rightmost digit. All the groups are to be added, and this rule is going to be valid for all the factors of this number. What are the factors of this number? This number I can write as 99 times 101. 99 has all the further factors, we have already done that, and 101 is a prime number, it cannot be factored. So this rule is going to be valid for all of its factors. Right, so there is no limit to this list, so I am putting it for you now. Okay, now quickly jump to the next part of the video. How do we check whether a number is divisible by 11 or not? You can remind your schools again. In your schools, you had done something like this: add alternate digits and their difference, and whether the difference is divisible by 11, the number is divisible, otherwise it is not. That's true. But again, let's see it how. Okay, so in the same factorization, same place values part, expansions part, let's see. So if my number is a 4, it is number ABCD. I have written it as in this expanded form, 1000A, 100B, 10C and D. Now I want to check whether my number is divisible by 11 or not. So for this D is never going to be divisible by 11, so it will remain as it is with this plus sign. And near this number 10C, do you see any part of the number which is multiple of 11? Yes, it is 11C. So I can split this number as 11C minus C. So 11C is going to be divisible by 11 anyhow, whatever be the value of C. So what is going to remain is minus C. Right? In this case, 100B. So is there any number near 100 which is multiple of 11? Yes, 99. So 99B is divisible by 11. What is going to remain is plus B. So it is plus B. And in this case, if I see, so here is a number 1001 which is multiple of 11. So this number can be written as 1001A minus A. Right? So 1001A is divisible by 11 and remaining is minus A. So this pattern will continue. So these are alternately plus minus and so on. So the rule which we have learned in school is fine, but we have seen it carefully now, which sum is to be subtracted from which numbers. So these are, again, we are making groups of single digits at a time, but now this time all the digits are not to be added. They are alternately plus minus. Okay, so I can conclude it in this manner. I'm using this different color now. So for 11, I need to make again groups of single digit at a time, but the groups are not to be added every time as in that case. In this case, now the digits are alternate plus minus. So I'm putting the sign plus minus, and this is to be done alternately with the first group from the rightmost digit being positive and then next negative and so on. Okay, and this rule is going to be valid for its factors as we have done earlier, but 11 is a prime number, so this rule is valid only for 11. Okay, do you remember we had done one more rule for 11? In this case, 11 is here also. Okay, let's extend this rule further as we had done earlier. What about a rule for 101? So how do we check whether my number is divisible by 101? Exactly similar, because 101 is 1 more than 100, so I can split my number as multiples of hundreds or 100 squares and so on. So as we had done for this 99, so I'm going to use the same part. So split the number like this. Now this 2-digit number CD, when it is divided by 101, it is not going to be divisible, so remaining part will be this CD with plus sign. and near 100 AB, is there any number which is divisible by 101? Yes, of course, 101 AB is divisible. So this number can be written as 101 AB minus AB. So 101 AB is going to be divisible by 101 always, whatever be the value of this 2-digit number AB. But the remaining part is minus AB. So again, we have a similar pattern that we are to make groups of 2 digits this time, and the groups are going to be alternate plus and minus. So only difference is that now this time group size is 2 digits at a time. So I'm writing it here. So make groups of 2 digits at a time. This grouping is to start from rightmost digit, last digits, and the groups are going to be added plus or minus alternately. The first last group, which is we are going to start from the rightmost digit, that is going to be positive as we have done here. The next one will be negative, and if the further one is there, that will be positive and then negative and so on. So let's take a quick example. So if I have a number, say 6-digit number 1, 2, 1, 2, 1, 2. So what will be the remainder when this number is divided by say 101? So I can make use of earlier rule also, but it is better to use this one here. So in this case, this I need to take groups of 2 digits at a time, and starting from the rightmost digit means this 2, and the groups are going to be alternate plus and minus. So this 12 is going to be positive 1, and then this next 12 is going to be negative 1. And this again next 12 is going to be positive 1. So there is one more digit, let's make it a 7-digit number. So this, let's say only 7 here. So this next 2 is going to be negative again. So I just need to simplify this value to find out whether my number is divisible or not. So this plus 12 minus 12, this part is divisible, cancel, it is going to give 0. And this plus 12 minus 2, it is going to give us 10. So that means when this 7-digit number is divided by 101, I am going to get 10 extra. So this number is not divisible by 101. So I need to subtract 10 from this number so that this number can become divisible by 101. I hope it is clear. Now going quickly for the next number, if my divisor is 1001, prior to that, this 101 is also a prime number. So this rule is going to be valid only for this number as for 11. Now for 1001, what is going to be the rule? The rule is quite similar, because now I need to make groups of 3 digits at a time as we have done here. So BCD plus this A. So this BCD is a 3-digit number. When it is divided by 1001, remainder is going to be as it is, this BCD 3-digit number with plus sign. And near 1008, do I have some number which is divisible by 1001? It is again 1001A. So this number can be written as 1001A minus A. So this is a similar pattern as we have been doing so far. So now I need to make groups of 3 digits at a time. This grouping will start from the rightmost digit. I am repeating this sentence again and again so that you don't forget this. And the groups are going to be alternate, positive and negative, with the first group from the rightmost digit is going to be positive. So this is the rule for this 1001. Now for what numbers this rule is going to be valid? Now 1001 is not a prime number, so we need to look for its prime factors. So its prime factors are 7, 11 and 13. So this rule is going to be valid for all these three, 7, 11, 13, and their combinations also means 77, 91, 143 and of course 1001. I hope it is clear so far. So let's move one step ahead also, as we had done earlier. If I need to look for divisibility by 10,001, so what is going to be the rule? I'm quickly writing the rule only as we had done earlier also. So now we need to make groups of 4 digits at a time, and the groups are going to be alternate plus minus, with first group from the rightmost digit being positive. And what this rule is going to be valid for other than 10,001? Its factors. It is also not a prime number. Now factors of this number are 73 and 137, and there is no end to this list. The rest part is up to you. For all of our exams for which we are preparing, these many rules are sufficient. The mostly used part is this 7, 11, 13 part for 1001, and this 27, 37 part. This was the rule to 999. Okay, so if we'll observe this whole table carefully, so we can see for the number 9, I have all these rules. For number 3, I have all these rules. It means I can take single digit numbers, 2 digits, 3 digits, 4 digits. I just need to add them. Right? What about the rules for 11? So again, there's not only one rule for 11, there are many rules for 11. I can take only single digits and alternately add and subtract them. Right? I can take groups of 2 digits at a time, because 99 is a factor of 11. So I can take groups of 2 digits at a time and add them all. Or if I come here, I can make groups of 3 digits at a time, because 11 is a factor here also. So I can make group of 3 digits, and then they will be alternately plus or minus. And I can come here also, because this 9999, this what is number has a factor 11. So I can make group of 4 digits also, and all the groups will be added. And if going further, I can come the next part also. In that case, what will be happening? So it will happen that I need to make group of 5 digits at a time now, and the groups will be alternate plus and minus. So for 11 there are infinitely many rules. For 9 also there are infinitely many rules. So this is the family of divisibility rules for 9s and 11s. I hope you understand it carefully. So please go through it again so that you can understand each of the concepts well. Thank you.